Good morning. I'm Earl Walker, and I have the pleasure this morning of interviewing Dr. Robert Livingston. Dr. Livingston, could you tell us a little bit about your early life? Your father, I understand, was a doctor.
That's correct.
In what field was he?
He was a surgeon, and he was interested in the nervous system. He was interested in pain mechanisms and wrote a book by that title.
Well, he wrote a book, didn't he, on that?
Yes, yes.
Can you tell us a little more about his interests?
Well, he started out at Harvard Medical School and interned at Massachusetts General Hospital. And one of the first patients that he had to care for as an intern had a bowel obstruction and resection, and he was asked by the resident to open a colostomy. And the resident said, get a blowtorch and a soldering iron and cauterize this loop of bowel that was brought out. And my father knew the man had suffered great pain from that bowel by the obstruction and was astonished that you could cauterize this. He thought it would be a terribly painful thing. What kind of anesthetic do you use? He said, you don't need an anesthetic. So when they cauterized this wound, the patient was anxious, but he lay back, relaxed, realizing that he didn't have any pain from that experience. My father became deeply interested in pain mechanisms on that occasion.
Well, that's a very, very interesting beginning. And can you tell us a little bit more about your father's experiences?
Well, he completed a residency in surgery and then went out to the University of Oregon at Eugene. And we lived there for about 6 years. And then he moved to Portland, Oregon, and was on the faculty. Ended up being professor and chairman of the surgical department. He wrote a book early on called Clinical Aspects of Visceral Neurology. And that was used as a text at Harvard and Stanford and Cornell and other places. He wrote on phantom limb pain and a good many other subjects. He was keenly interested in how the brain works, and of course I became infected with that, and my brother as well. My brother, 4 years older, went to Harvard Medical School also and took a residency in surgery and practiced neurosurgery.
And was your mother also in the medical field? Or?
No, she was a farmer's daughter, actually a man who ran a mill for grain elevator, and then was a farmer up in northern Alberta. And so we spent our summers riding horses and driving tractors on a great ranch in northern Alberta.
Were there any special incidents that you recall in your school days that influenced you in going into the nervous system?
Well, when I was in high school, I had a biology teacher I was very fond of, and used to come home and regale the family with stories that were told by the biology man about how physiology and biology worked. And my father became a little bit tired of this bringing in the high school teacher and began to call him John the Baptist. Anyway, I was interested in biology and used to go on rounds with my father to see patients that he'd taken care of. And it was a very exciting experience. By the time I left for college at Stanford, I knew that I wanted to go into medicine. I knew that I wanted to learn as much basic sciences relating to medicine as I could.
Now, where did you serve your internship following graduation?
Following graduation from Stanford and then Stanford Medical School, I was an intern and assistant resident in internal medicine at Stanford University Hospital under Arthur L. Bloomfield. Very exciting experience. We had penicillin for the first time, and it was introduced by the National Research Council, and it was under a very strict protocol because it wasn't available generally.
Were you working with Dr. Kiefer at that time?
No, Chester Kiefer I knew. He was chairman of the committee that
Yes.
overlooked this. One of the exciting things was that I was able to give penicillin for the first time to a patient with syphilis.
Oh, yes.
We didn't expect that syphilis would be susceptible to penicillin because it was a spirochete instead of a gram-negative organism. And so it was almost a year and a half into the program before we tried penicillin on syphilis. And I had a dark field set up next to this patient's bed, and we could see the spirochetes. And within about 4 hours of introducing a intravenous penicillin, because it was too irritative to inject, and it couldn't be taken by mouth, within about 4 hours, the spirochetes were looking kind of drunken, and within 6 hours, they were gone altogether. And the man never became seropositive.
Very exciting.
It was very exciting. At that time, 5% of all the patients in hospitals, private and public, had tertiary syphilis. Yeah. And now you can hardly find a case to demonstrate. Very exciting.
Did you do any further studies following that?
Well, not with syphilis, and not with infectious diseases. But following my residency, I went into the military and served in the Navy, in the Marine Corps, and had the great privilege of building a hospital for wounded Okinawans and wounded Japanese prisoners of war throughout the whole campaign. Mm-hmm. We landed on Love Day, Easter Sunday, 1945, and stayed there the whole time and had a wonderful experience taking care of badly wounded people.
And then after the war, World War II, where did you go?
Well, toward the end, when the atomic bomb was dropped on Japan, I was sent to China. I had studied Chinese for 3 years at night school during medical school, and I was taken over as a translator because they hadn't expected to need Chinese. And I participated in the surrender of the Japanese forces to the American Marines in North China.
And what part of China were you assigned to?
Tianjin and Peking, and I went down to Shanghai a couple of times, but mostly in Tianjin. I met Mao Zedong and Zhou Enlai and Zhu De and other people in China at that time. And I stayed there about 10 months. And
that would be very exciting.
Then came back to be discharged in San Diego, and then went up to San Francisco where the American Medical Association was having a meeting. And there I met John Fulton, and I had read some of his books, and so I presented myself to him, and he saw me in uniform and asked what I was going to do, and I said I had no plans. And I said I was interested in physiology, and he was chairman of physiology at Yale, and he offered me a job, $1,800 a year.
Well, in those days, $1,800 a year was
not
pretty
bad.
Good salary. Yes.
Yeah, and he sweetened it up by the time I got back to New Haven to make it $2,000 a year, which is magnificent. Anyway, I enjoyed very much.
In what year?
That was 1946.
46. Mm-hmm.
I stayed with John Fulton from 46 to 52, but I spent 2 years abroad doing postgraduate study, but under his aegis.
Where were you there?
I was in Switzerland with Wyss, and in Zurich with Hess, and in Oxford.
Was Hess doing his work on the hypothalamus then?
Yes, exactly. And he had ways of implanting electrodes in freely moving cats, and we studied eye movements from the medial surface of the frontal lobe. And
did you work with him?
Yes. It was very exciting.
What kind of a chap was he to work with?
He was a marvelous guy. That fall, he was given the Nobel Prize in Physiology and Medicine.
Yes, he was very excited about that, because I understand that prior to that he was been a bit disappointed that his work had not been recognized around the rest of the world.
Well, it was published mostly in German, and even in the German language, the German-speaking people didn't pay much attention to the Swiss scientists, and so he was somewhat isolated. But he was a very fine man, a very generous man, and very able. He had some wonderful technical support, and he raised money locally to carry out his experiments, and he was a real pioneer.
Did you know his son?
Yes, I did.
He was also in
yes, exactly,
the field.
Exactly.
And were you working with him?
Well, we did a little bit of work together. He was just starting out at that time, and we fell into each other's orbit and enjoyed each other's company.
Oh, yeah. Well, now, from there, where did you go?
I went to Oxford for a period of time, and then worked in Paris also with the Fessards.
Oh, yes.
Yeah.
Was LeGros Clark working at that time in Oxford?
LeGros Clark was at Oxford at that time, and I worked mostly with Paul Glees, who had left Germany and was settled in Oxford. We worked on the distribution of sensory fibers ascending in the dorsal columns, their source and destination, and it was very orderly and enjoyable anatomy.
Well, then you came back to Yale.
Yes.
With Dr. Fulton.
Yes.
And what were you working on then?
Well, we started out working on the area 13 of the orbital surface of the frontal lobes. And some earlier work had been done by Ted Rue and Peg Kennard, showing that after ablation of that, the animals had a difference in temperature regulation. They tended to have warm, relaxed vessels in their skin, and they also were hyperactive. And John said we should stimulate that area electrophysiologically and see what happened. And we got changes in blood pressure and stomach contractions and respiration and so forth. So this was the first evidence of visceral representation in the cortex.
Yeah, right.
And it turned out that this is the area 13, where the vagus nerve has its only cortical representation. Then we began mapping visceral responses all around the cortex, and we began to find on the cingulate gyrus and the temporal lobe and so forth, and it turned out to be the limbic system, which had not then been named.
Well, now, when you were there, they had rather an exciting group of neurophysiologists working with Fulton.
That's right.
Do you recall any of those in particular?
Yes, Ted Rue was there, and shortly, I guess 1968 or so, went out to found the Department of Physiology at University of Washington. Harry Patton was one of his students who went out with him, and Patton and Rue continued.
Margaret Kennard there?
Margaret Kennard was not there at that time, but she dropped by from time to time, and I met her then, and I was very honored.
Carlisle Jacobson?
Yes. And I had the pleasure of meeting you at that time. It was a meeting ground for many people. John Fulton was very hospitable, and as a person and as a scientist, and a prolific man in every respect.
And how long did you spend in Yale?
From 46 to 52. But as I say, 2 years were spent abroad.
Yeah.
I also had a concurrent appointment in psychiatry at Harvard and spent most of a year up there doing some research with Harry Solomon in the Psychiatric Institute.
Well, now, from there, where did you go?
Well, while I was there, I also worked with the National Academy of Sciences and National Research Council. It was 50 to 52. I used to go down Thursday nights in my little Chevrolet and work Friday, Saturday, Sunday, and then come back Sunday night to Yale. And I worked with Det Bronk, who was a neurophysiologist, who was a president of the National Academy.
Well, was this in Philadelphia or in Washington?
This is Washington, D.C.
In Washington.
Yeah. And Det was president of the Academy, and Bill Ruby was chairman of the National Research Council. I worked as executive assistant for both of them, and my job was to write draft legislation that related to the changes that were taking place in science and the relationship of science to government. So I participated in the founding of the National Science Foundation, the Atomic Energy Commission, science advisor to the president, science advisor to the Secretary of State, and other offices. It was a very exciting time because...
It must have been, yes. It was, can you tell us something about the persons that you met in Washington at that time?
Well, gosh, there are so many, and they're all so high above my level that I could hardly give a fair muster of them. But almost everybody that you know in government was somehow related to committee action or personal action that I had the privilege of contributing.
And people in the medical field, did you meet any outstanding characters?
Well, yes. My whole life has been doing that. And the Academy spawned the Institute of Medicine, a few years later, but we laid the groundwork for that at the time I was there.
And then, where did you go from there?
I went to UCLA and helped to start the medical school there. I came a year after it had begun, and my responsibility was to teach anatomy and physiology of the nervous system.
Well, was Ted Magoon there at that time?
Ted Magoon was there. He was a great attraction to me going there, and Jack French was there, and John Field. So I had dual appointment in physiology and anatomy.
Were you in the neurological field at that time, or was?
Yes.
I see.
Yes, and we drafted the legislative authority for development of the Brain Research Institute, which is now quite a well-founded organization.
Well, can you tell us a little more about the Brain Research Institute, the people who were there, and the individuals who were outstanding at that time?
Well, Ted Bullock was in zoology, and he was a great friend of the medical school, and we did some research with him. Jack French, of course, had focused his attention on the Veterans Hospital at Long Beach, and we drove back and forth to do research at Long Beach. I was very fond of Jack, admired him enormously, and we did a number of studies together. We recruited Ross Adey from Australia, and I was his U.S. sponsor. And we had Raul Hernandez-Peon from Mexico, who was an outstanding person. I'm sorry, he died in an automobile accident several years later. And let's see, Magoon and Lindsley and many other people were just stars. And it was at that time that we began work on the reticular activating system.
Yes.
And found out that anesthetics were acting there, and that if you stimulated that area, you could arouse a sleeping animal. And then Jack French and Ross Adey and Pepe Segundo from Uruguay, and I did some research on not only arousal, but cortical projections to the arousal system, and they were segregated cortical territories that projected into the reticular activating system and could arouse a normally sleeping animal without disturbance, but just waking him up from several of these patches of cortex. We had a great time. Jack had a marvelous sense of humor and lots of drive, and was very well settled with Dr. Edwards, who was head of the Veterans Hospital. He used to play golf with Dr. Edwards, and when he was behind Dr. Edwards, he would say, "Dr. Edwards, you're playing magnificently today. I'd like to have some hints from you. When you do your backstroke, do you inhale or exhale?" And stories like that would upset Dr. Edwards.
Yes, I can understand.
It wouldn't matter whether he was trying to deny having heard that or keep it out of his mind. It would nevertheless interfere with his game.
Do you play golf?
No, I don't, but I admire Jack, and that was my closest association with golf.
Oh, yes.
Stories.
And then, when did you leave Los Angeles and the Research Institute?
Yes, I stayed there from 52 to 57, and I was attracted by Seymour Ketty to take his place when he left as scientific director for the Mental Health Institute. At that time, the Neurological Institute was just being founded. Pierce Bailey was head of that, and I made a part of my recruitment that I would join the two institutes as scientific director and combine their intramural research programs. It seemed to me not to make any sense to have a separate neurology and a separate mental health research foundation. Bob Felix was director of the Mental Health Institute, and altogether we had a very interesting time with Jim Shannon and others. It was a time of great expansion of the National Institutes of Health, both for intramural and extramural activity.
So you were one of the people who got the National Institute of Neurological Diseases and Blindness.
We got it started.
Yes.
Right.
Can you tell us a little bit about that?
Well, Pierce
Prior
Bailey.
to that, it was combined with the mental health.
Well, it started as kind of an offspring of the Mental Health
Yeah.
Institute, and then it became a separate institute for its own funding and its own intramural research program. The thing is still thriving, and I'm very happy to have been associated with it. I left the institute on a part-time basis so that I could do laboratory research and also library research. And I was named by Marty Cummings, who was the director of the National Library of Medicine, as the first national scholar of the National Library of Medicine. And it was possible to run a laboratory of physiology and at the same time do a good deal of library research. One thing that happened then, Earl, that is of interest, I think, in 1961, I hired a man named Bruce Waxman, who had a PhD as well as an MD, and he was very interested in the technology supporting medicine. So I said, tin cup all of the directors of the NIH and go to MIT and obtain a contract to build a small computer.
Oh, yes.
The reason was that all the computers up to that time were large room-sized computers. Right. And at the NIH, we had a computer, Burroughs, from England, that was in a separate building. And we'd be in the middle of experiments with patients with implanted electrodes and animals, monkeys and cats and so on. And then the computer would crash, or they would stop for engineers' time, or they would stop for the budget or payroll or something like that. And we were interrupted so many times that it was just unconscionable. And I said that we had to have a computer that could be controlled in the laboratory itself, and so that was the aim. And I said it had to fit on a secretary's desk, and when you stood up, you had to be able to look over the top of it. So that put the parameters for size. Mm-hmm. And MIT took the contract, and in Lincoln Laboratory, in the under the aegis of Walter Rosenblith, whom you know, two graduate students, Wes Clark and Charlie Molnar, created a small computer. It was an A to D and D to A converter, and it had tape drive and had punch tape output. And you moved things around without a mouse, but by touching the screen with a light pen. And this was the beginning of the Link series of of computers that were used neurophysiologically under a committee of Mary Brazier, and they made about 20 of these and distributed them around the country and got feedback from the physiologists as to how useful it was and what should be done about modifying it. And then when it was pretty well decided how it should work, a company was sprung off, and it was the DEC company. So DEC was the first one to have a small computer. The computer was called the Link, for Lincoln Laboratory.
Well, now, were you using a Link at Los Angeles?
Well, it was used in Los Angeles later, and
I see.
they used it as soon as they became available from the Lincoln Laboratories. One of the funny things, I made a visit to MIT to see how the progress was going on this computer, and Wes Clark and Charlie Molnar introduced me to the idea that a grid could be made on the screen, and you could make a maze, and then you could have a rat, which they presented, that would run the maze. Mm-hmm. And then they drifted off to do something else while I conducted research with this rat. And I could build different kinds of mazes with a start box and a finish box. The rat would move till he touched something, and then he would turn at right angles and so on. When he got to an alley that he found he was boxed in, he would go back to test some door that he hadn't tested. Anyway, he stopped, and I called to Wes and Charlie, "Come here, I gotta have some help." And they said he needs cheese. So they brought a piece of Swiss cheese in the computer out and presented it to the rat, and the rat ate the cheese. And he still wouldn't move. And I said, "What's the matter now?" He says, "He's got to poop." And so the rat put out a couple of pellets, and we took those away, and then the rat cleaned his whiskers and started going on the maze again. As soon as he had finished the maze, then he could run it perfectly. Mm-hmm. Anyway, this shows the kind of talent and excitement and pleasure that grew up with those computers. And those were the first small computers, kind of exciting. Now you can have a power book that will have more power than the Burroughs machine that NIH had.
Well, now, when did you leave Los Angeles to come down to San Diego?
I left Washington to come to San Diego.
Oh, I see.
I was there as scientific director for the two institutes until summer of '64. And then I came to I was the first professor in the medical school at UCSD, University of California, San Diego, and founded the Department of Neurosciences. This was the first department of neurosciences in the world. There are now about 50 of them. I had the pleasure of living with Ted Bullock, who had come down from UCLA to study mathematics on an NRC fellowship. And the two of us were familyless because his family was in Los Angeles, mine was in Bethesda until the school year ended. And we fell into each other's orbits and found that it was very exciting designing a new department. And I must say, he gave it class.
Well, could you tell us something about the work that you've been doing in San Diego here?
Well, one of the things that we did that I found interesting was we decided to use computers to demonstrate brain structure. And we did this beginning in 1964 and culminating with a film made in 1976. We did this by building a giant microtome, such as Paul Yakovlev had developed at Harvard.
For whole brain sections.
For whole brain sections. Yes. So a very clever technician came from Purdue University to join us, and he had done serial sections and imaged the cut surface of the block for plants in the Department of Botany at Purdue under Postlethwaite. And this seemed to me a marvelous thing to apply to anatomy of the human brain. Yeah. So Roy Mills carefully removed brains and perfused them conscientiously with artery perfusion, and then put them in vats so that they could change temperature rising and falling and pressure increasing and decreasing to get rapid and maximum complete fixing of the brain. Then he mounted them in paraplast, and then we put them in this giant microtome, sliced the surface. We could cut as thin as 5 microns, but they're too flimsy to handle, so we cut ordinarily at 40 microns. Mm-hmm. Well, each section was taken in a fixed camera and fixed face of the block. You could take a motion picture. Right. And each picture then made a film. We cut 72 whole, normal human brains. And you could then look through a motion picture to see coronal or horizontal or sagittal sections. And it was very exciting because we soon found that one person would have twice as big a caudate nucleus as another, even though they were normal. And we always wanted to know what the life history was. We took a couple of these brains and digitized them so that we could have about 20 major structures separated. And Evans and Sutherland in Utah, Salt Lake City, provided us with a picture system, a computer, which allowed us to have a graphic display of these structures. We could let medical students come into the laboratory anytime, day or night or weekends. They'd find a key in the fire hose box and go into the laboratory, and they could start the computer, and they could ask for this brain images, and then he could have, with or without labels, any of 20 or so structures. And they could move them, tumble them, fly through them, and so forth. And by golly, they would learn neuroanatomy three-dimensionally very easily that way. It's like going to the zoo. You see a giraffe and an elephant and a hippopotamus and an alligator, and you never forget them.
That's right, yeah. Well, now, Did any of these students of yours continue on in the field of neuroanatomy?
Oh yes. As a matter of fact, we started a brain anatomy project. It was called the Brain Mapping Project, and that's still thriving. It's been spread out now to about 7 universities, and it's better and more prolific than it ever was. And it's going to, well, I'll say something if you like about my projection for the future.
Until now, sure.
Until now, it's not been possible to do microscopic anatomy on these sections and do it for the whole brain. Mm-hmm. But I project that within 5 to 7 years, with increased speed of access of information and condensation of memory, that it will be possible for computers to handle a whole human brain at microscopic levels of detail.
At what range of magnification?
Well, if you cut 40 micron sections, you can then have the sections stained with 3 stains that will give you neurons and glia and endothelial cells with separate fluorescent colors. And you can have a confocal microscope that will look through all of these sections, and they can make 8 different planes through the 40 micron thickness, and this allows you to have a 5 micron cubed analysis of the brain. This involves about 2,000 gigabytes of memory, so present computers can't handle it and can't assemble the information from one brain to compare with another quickly. But I predict that before about 2000 AD that it should be possible. And this is very exciting to me because we would then realize what we had wanted so much to have at UCSD, namely the life history to correlate with the microscopic brain structure. We call it facetiously endophrenology, phrenology inside the brain. Now there are lots of organizations in the world that are taking care of terminally ill patients who have no neurological problem, and whose life history can be analyzed while they're patients in hospital or in a rest home. And then we could get very thorough details of their life history and their competences and accomplishments and so forth, and correlate those with detailed neuroanatomy.
So you can do this in the living individual.
Well, you can't slice the brain.
Well,
you did that. But after the individual has given his life history and has died in comfort, then his brain can be analyzed and his brain structure correlated with his life history.
Well, what else do you see in the future for the neurosciences?
Well, computers are certainly a great help. More than that, the knowledge of brain evolution and brain development. For example, we did a number of embryos 3-dimensionally, and you can make one embryo grow into another on a computer. We used slides that were taken from the Carnegie Laboratory of Human Embryology at UC Davis. Now, I think the computers will be able to do several things. One is normal growth and development, and in the course of that, find out more strictly what is the role of, say, folic acid, folate, in disorders of the ventricular system. You can find out what is normal development and what may be development interfered with by alcohol or drugs or other things in experimental animals. And you can study children who have disorders. There's a Williams syndrome and many others where people have trouble with language and so on, but don't necessarily have lesions in the language centers that we think of clinically. Well, with computers, it should be feasible to study normal development and lots of pathology, as you can imagine, and trauma and almost anything you want. Now, if you have a series of, say, 100 normal brains, you begin to get some statistics on what are normal variations.
Yeah.
And then you can allow a surgeon who wants to explore a certain nucleus or territory to fly through and look it over and see which approach might be most appropriate. And then compare MRIs. MRI scans are so good now you can make a three-dimensional picture of the depth as well as the surface of the brain. It's exciting to have your own brain in detail imaged with MRI, non-invasive business. So the growth simultaneously of imaging, clinical use of imaging, and the anatomical work that can be done in fine detail will allow the surgeon then to look through the file of normal variations to see where his patient lies and anticipate better than he can now what kinds of opportunities and problems there may be.
Well, now, do you envisage that you can carry this into the operating room so that the surgeon, while he's actually has opened the skull, will be able to see some of the nuclei of the thalamus, for example?
Yes, I think you would have imaging in the operating room that would be based on images preceding, both related to that patient and to comparable patients, and that the surgeon should be able to follow his surgical procedure with an amplified view that would be very enabling. He would be able to see ahead of himself in going into depths.
What other future developments do you see in the field?
Well, this is, I've been suggesting mostly anatomical and pathological investigations and support for research and clinical application. But it's not just the anatomical, but I think the physiology is just enormously exciting, and the conjunction between molecular biology and physiology is just entrancing. As you know, the word physiology in its Greek origins meant all natural knowledge. And in some respects, I still believe that physiology is going to be the secret of man's understanding himself, both as a warrior and as a peacemaker and as a social being. I think that physiology deserves to rank as a very prime discipline for helping people establish a better world and a better life, and for contributing to the excitement of knowledge and insight.
Well, tell me a little bit, what do you envisage the teaching of physiology to be in the future? Well, obviously, with the computer and other techniques that are available at the present time, it's changed considerably.
Yeah.
Since we were in Fulton's lab.
Right. When I established the Department of Neurosciences at UCSD, the National Library of Medicine gave us an award that continued for several years to develop what we called the Neurosciences Study Plan. And this was a carousel where a student would have access to a microscope, to slides of various tissues and so forth, to models of the brain and books and everything that he needed, really, to invade this area and find it less formidable. And the study plan would allow the student to follow his own desires, to go after some particular subject or to move from one subject to another. And now, of course, this kind of material can be presented on compact disc, so that a student working at home without having to have an elaborate carousel could decide what he wants to study today and go into it and find all the ramifications that go out down to the molecular level or up to the clinical level as he would like. Follow his own path. I think that's the best support of education, to let the curiosity of the student.
So the student will be able to do much of the work at home that he now does in the university.
Well, yes, and that would allow him to study at home and then go to the university for the fruitful interaction with other students and with professors and so on. but it would allow anybody, a resident or a practicing physician, to have access to the same kind of materials, basic and clinical, at home.
Well, does that mean that lectures as we now know them will be pretty much out of date?
I don't think so. I think lecturing, both for the student and the professor, one of the best ways to communicate and transmit knowledge. I still think that Mark Hopkins sitting on one end of a log and a student on the other is the best model for education. I don't believe that professors will be out of work or that students will fail to recognize the pleasure and satisfaction of working with somebody who's done the things that they want to be able to do.
Well, supposing we leave that for the moment and come back to your personal life. What are your interests outside of medicine?
Well, I grew up in Oregon and was very excited about the beautiful mountains and began to climb mountains. My father and mother were hosts for Western Surgical Society meeting, and they planned an excursion to climb Mount Hood. I was 9 at that age, at that time, 9.5, and I climbed the mountain with them, and I got a real bug. I began climbing and continue now. Since then, I became a guide and used to guide on Mount Shuckson and Mount Baker and Mount Adams and Mount St. Helens before St. Helens blew its top. And the only mountain in Washington I didn't climb as a guide was Mount Rainier. The Whitaker brothers had that sewed up, but I went with them several times as assistant guide. And then I climbed all the mountains in Oregon, Mount Hood, Mount Jefferson, Three Finger Jack, Mount Washington, Mount Thielsen, Mount Scott, Mount McLaughlin, and down in California, Mount Shasta and Mount Lassen. So all that range of the Cascades, with the exception of Rainier, I was an official guide for during summers. And
well, now, have you been to other mountains, the Himalayas? Any mountain work?
I have seen the foothills of the Himalayas from the Indian side. I'm a science advisor to the Dalai Lama, and he has his government in exile in Dharamsala, India, and that's right in the foothills of the Himalayas. Summer before last, I went with Robert McNamara and other friends to Baltoro Glacier, which is in Pakistan. And that's one of the great long northern hemisphere glaciers, and we went up to the base of K2, which is the second highest mountain in the world. I wasn't able to go all the way because I fell and broke some ribs and had to retreat. But every summer since 1952, I've gone climbing with McNamara and other people. This May we're going to be hiking in northern Italy, and then this summer we'll be hiking in the Sierras. And it's a great way to have a peripatetic seminar and enjoy the out of doors. I've climbed Mount Hood 31 times and many other mountains several times in Europe, as well as Mount Blanc and the Matterhorn and Weisshorn and Rothhorn and other horns.
Well, now, has your research included altitude studies?
Yes, at Yale, John Fulton had a high altitude chamber, and I was in charge of that chamber for several years, and we used to indoctrinate pilots and engineers and so forth in high altitude physiology and the protection required by taking oxygen and how to handle that. And we studied explosive decompression in case an airplane lost its pressure at high altitude. And we studied what could happen if a fighter pilot was at very high altitude and had to bail out, and whether he could fall fast enough without opening his parachute to get back to a place where the pressure was sufficient for him to be able to breathe. And he could go to 80,000 feet and drop far enough to get down to about 15,000 and then open his parachute and be able to breathe. Otherwise, he'd have to carry oxygen with him.
Yeah. And have you done any work in South America and the mountains there?
No, I'd be ready to go, Earl. I did some traveling down there, though, with Bullock and Lindsley and some others on the Amazon. We went to Belém and did some work there in the Museo Geldi with sloth, and tried to figure out what makes the sloth so slothful. And then we studied a number of animals, fish and dolphins and sloths and tapirs and so on, up near Belém, up near Manaus, at the junction of the Rio Negro and the Amazon. The Amazon is a gorgeous country and marvelous forests, and I'm just awfully concerned that we're despoiling them by cutting the forest back.
Can you tell me some of your other interests or hobbies?
Well, we began sailing when I was a kid, and I joined the Sea Scouts, and we fixed up some old whale boats that had been abandoned and made standing lug rigs for sailing them, and we sailed from Portland down to Astoria, and my family then bought a boat called a Columbia River One Design, a sloop 26 feet long, and we sailed that up and down the Columbia from above the Dalles to Astoria. And one time my father and I made a trip to cross the Columbia River Bar and go up to Gray's Harbor and up to Juan de Fuca Straits and so on. And later on I sailed out of Anacorta in Washington to go up to Princess Louisa Inlet and other places. When I was 15, I had a job as a bosun on a small motor tourist boat that went up to Alaska from Seattle, and went up to Juneau and Ketchikan and Sitka and so on. And then 59 years later, I went back last summer and took the same trip. It was very exciting. I was up on the bridge of the ferries and could look at places where clear cutting had taken place in the forests, and where old villages with totem poles and so on had been destroyed, overtaken by development. A good deal of a sad trip. But when I was there first in Juneau, I went to a little gift shop, and the man there took a fancy to me, and he gave me a small ivory head carved by Eskimo, and it was well carved and painted, and when you tilted it forward, the eyes popped out and so on. He said that that would allow me to look at glaciers anytime I wanted without having to ask permission.
Tell me, tell us a little about your family life.
Well, my father was a surgeon, as I mentioned, and he was interested in our earning our way in life, so I began carrying newspapers when I was a kid of 12, and carried until I went to university, and I worked at university for 50 cents an hour as a gardener for Herbert Hoover and for other people in the Stanford community, and I earned all my way in college and medical school. That was probably a good thing to do, but it seemed to me to be pretty hard work, but enjoyable.
Do you have children?
And we have 3 children, all girls. A friend of mine who has 2 boys and 2 girls told me how to have a boy. You know, the male is responsible for the sex of the offspring. And his advice to me was, Bob, you've got to draw way back on the bow.
It didn't work.
No, but these girls are good. They,
what are they? What fields are they?
One is a lawyer who's a maritime lawyer in San Francisco. That's Louise, the eldest. She works on getting out of court settlement of cases of passengers who want to sue a cruise ship, let's say. And my middle daughter, Dana, is a publisher of books in France, in Paris. and she publishes in both French and English and translates both directions, mostly from French to English. And she also is an artist and a musician, and so she illustrates the books and accompanies herself on the piano. The youngest is a designer. She designs for Esprit. She worked for them for several years in San Francisco and then got tired of San Francisco, wanted to move to Oregon, but she has a contract with Esprit to continue her work. She designs for Pottery Barn and other organizations. She's now building a house that will be independent of outside power, using careful insulation and wind power and photoelectric power.
None of these were interested in medicine, or
no, I think
any particular reason why they were turned off?
I think they are interested in medicine, and I think they enjoy hearing about it and knowing about it, but they didn't want to follow a career in medicine. They were more attracted to the things that my wife was talented in, art and music and good cooking.
Mm-hmm.
All noble enterprises.
Well, now, would you like to tell us anything about other adventures that you've had in your life?
Well, in sailing, I enjoy that very much, and we bought a second-hand boat. It was designed by John Alden. It was a 44-foot yawl, the only yawl that he designed for himself in the series called Malabar. And this was a beautiful boat. We sailed it all over the Chesapeake Bay when I was at the NIH, and then we sailed it down to the inland waterways to the Bahamas, and we sailed.
Are you
it
a
up,
fisherman?
We sailed it up to Woods Hole and Maine and thereabouts. No, I don't. Well, I do some fishing, but at sea, mostly for sustenance, have fresh provender. I also sailed across the Atlantic from West Palm Beach to Vigo, Spain, by way of Bermuda and the Azores as navigator on a 48-foot steel ketch built in Holland. That was an enjoyable experience. I'm prepared to go to sea again anytime.
Do you have any adventures on those trips across the Atlantic or elsewhere at sea?
Well, one of the surprising things is that at sea, and I was on an expedition called Capricorn for the University of California. It lasted about 9 months, and we went around a big area of the Pacific. I'm digressing here. We went out to see the Mike shot, which was the first hydrogen bomb. It wasn't a bomb, it was really a test device. They thought it was going to be 7 megatons, and it turned out to be 15 megatons, and a little bit of an arithmetic mistake. Anyway, from that point, we went to islands on the equator and south of the equator and made a big circuit through Tonga and Tahiti and so on, over to Easter Island, Rise, and so on. Anyway, we circumnavigated a territory that was larger than the surface of the moon, and used 2 ships. I was physician for the expedition and chief diver, and we had 75 hours of diving time and explored submerged atolls and underwater volcanoes, and had a great time. Well, in other adventures, beside mountain climbing and sailing, I am very taken by the fact that we have nuclear weapons. In college, I was attracted by a book in 1937 called Atomic Physics, written by a Princeton University faculty. And I asked the physics department if I could do some special study. So I worked with Norris Bradbury, who later succeeded Robert Oppenheimer at Los Alamos. And Norris Bradbury had me come Tuesday evenings to his house. His wife would serve us banana cake and tea, and we would talk about atomic physics. One day he threw a paper down on the coffee table, and he said, "Bob, calculate how high you can raise the Empire State Building using 1 kilogram of uranium-238 bombarded with slow neutrons. A paper by Hahn and Strassman had shown that when slow neutrons bombard uranium-235, they produce barium. Mm-hmm. And Dr. Bradbury told me that you could trust Otto Hahn was a good physical chemist and wouldn't be mistaken about having a clean setup, and that meant that the atom was split. It wasn't called fission then until a biological image of dividing the nucleus was suggested. But we could calculate how much mass was lost in the course of that splitting, and it was necessary for me to calculate then, using the E equals mc square formula, how high I could raise the Empire State Building. So I raised it about 6 kilometers, making a sky hook with 70% efficiency and cables that would pull the Empire State Building up by its roots, and I calculated its weight and so forth. But that was very impressive.
It certainly would be.
And I didn't think about this kinetic energy as a bomb. Leo Szilard had thought about it as a bomb. Mm-hmm. And so in Okinawa, when I was running that hospital for wounded natives, one day we were driving around picking up blood that was out of date so that we could use non-hemolyzed blood for women and children. And radio told us that an atomic bomb had been dropped on Japan. And I asked Champlin, the driver, and Bunis, the corpsman, with me to stop the truck, and I sat at the side of the road and I thought about it. Uranium is a very common element. In many beaches of the world, the 2% of the sand is uranium. Yeah. And in the mountains, there's lots of it. And so it's accessible. Now, if you get the kinetic energy to be an explosive force, there's an unlimited number of bombs that can be made. And we have a horrendous number now, 60,000 or so, of which maybe 100 would destroy the planet as a habitable place to live. And with 100 or so, you could destroy human existence. I think this is the most important fact of modern science and technology. And I think it ought to be uppermost in the minds of physicians and the public and world leaders and so on. It's unconscionable that we should allow these weapons to continue to persist in our midst, because by accident or inadvertence or by mistaken judgment, it would be possible to destroy the world.
Well, do you think it's possible to prevent such accidents?
Yes, I think so. And to prevent such accidents, you have to get rid of all the nuclear weapons. This means we have to make a powerful, legally powerful, and technically powerful, and strategically potent international organization that can make an inventory and can see to the disposal of and dismantling of weapons. We should be going at that full tilt. That should be the prime objective of our government. Now, there's an organization called the International Physicians for the Prevention of Nuclear War. Bernard Lown has been the head of it for many years, and that organization, I think, is doing a good job. They got a Nobel Peace Prize in 1985 for that work informing the public and world leaders. I've worked for them as an emissary. For example, I went with Lars Engstedt to 6 Arab countries, to Egypt and Syria and Jordan and Iraq and Bahrain and Saudi Arabia, to persuade Arab doctors not to go into the nuclear business and to help the world disarm nuclear. I also was ambassador to His Holiness the Dalai Lama, and I got involved with him through holding mind and life discourses between Western neuroscientists and Eastern philosophy and attitudes toward healing. I became very closely associated with him, and he named me his science advisor. He has one and only. And I'm going to see him Wednesday this week and spend about 5 days with him in Hawaii, and then come to San Francisco to moderate a dialogue between him and the faculty at Stanford. He's a wonderful man, and he's aiming to bring peace and compassion and tolerance to the world. Now, I work with Bob McNamara. We came out of the woods in our peripatetic march one summer and decided that the world needed to have global cooperation. It was absolutely essential. Without global cooperation, we won't be able to have a secure world. Without global cooperation, we won't be able to redress the neglected opportunity to feed children adequately, to overcome the poverty and injustice in the world.
Dr. Livingston, I noticed that you have a number of books here. Could you tell us something about your writings in these various subjects?
Well, the big red book here is the latest edition of Best and Taylor, edited by John West. I wrote 12 chapters on neurophysiology, and I wrote that for this 12th edition and for the 11th edition
that's
back in '85.
For medical students.
Medical students. Well,
and do your chapters include all aspects of neurophysiology, or are you limited pretty much to certain specialty fields?
No, it's supposed to be general and supposed to be inclusive, but I stupidly omitted a full discussion of the cerebellum. I discuss the cerebellum tangentially when I talk about other parts of the brain, but the cerebellum is unfortunately neglected there. But the rest of it, I think, is fairly comprehensible and concise.
And as
the last two editions, 11th and 12th, 1985 and 1991, I guess it was, are the editions that I contributed. Also, when I was at the NIH, I was responsible for drug addiction problems. There's a drug addiction research center at Lexington, Kentucky, associated with the U.S. Public Health Service hospital there. And my responsibility as scientific director for the Mental Health Institute was to be responsible for that project, and also to be responsible to the United Nations to identify drugs that are addicting. It would be interesting now in the connection with the tobacco that's being analyzed in that respect. I think tobacco is an addicting drug, but I didn't state that officially at that time. Also, I was responsible to the Food and Drug and Narcotics Division to make these identifications. We held a symposium in Washington on narcotic drug addiction problems, and this is précis, this is proceedings of that symposium, and I think it's a very important document. It's unfortunately been allowed to run out of print, and one reason that I think they let it run out of print was that it is not in correspondence to the idea of war against drugs.
Oh, I see.
The problem with having a war against drugs is that you raise the ante, you raise the price, and you increase the chance of having cops and robbers get together, and you make it a much more difficult social problem, because for a small amount of marijuana, for example, a youngster can get several years in jail automatically without recourse. Having mandatory sentences and having very severe sentences doesn't stop people from taking drugs or trading drugs. It makes it somewhat more exciting. But I think we've got to learn from our experiences with alcohol and prohibition and with tobacco as it's now emerging. We've got to learn to handle these things without enormous penalty to those who are engaged in, trapped by the addiction experience. But we've got to help them overcome the addiction and lead a more normal life. And that is not by punishment. You don't shape behavior very well by punishment. So this is an important document.
What positive means do you suggest to
education
limit or eradicate these?
Education is terribly important, and medical and psychological support is very important. and then having the drugs controlled as we control many other drugs. One of the troubles with having a war on drugs is that it makes the price so high that then it becomes itself a venue for exploitation. For example, the CIA raised drugs in the Far East and then sold them to our troops in Vietnam, addicting them in order to raise money for covert operations. Well, that's a very bad situation to have our government involved in.
Well, some people have advocated eliminating all such controls.
Well, I think eliminating the controls would be bad, just as eliminating control of alcohol would be bad. I think there ought to be restrictions on age limits and quantities and so on, and some accumulative record of people who have repeated accidents relating to drunkenness or drug abuse. But I don't think that it should be that you build more prisons and make more mandatory sentences and charge particularly young people with a burden for the rest of their lives of criminality, of something that they were enticed into partly by the high price of the drug. Mm-hmm. If the youngster can impress his friends and maybe buy a fast automobile or pay his way through college by dealing a little bit in drugs, is too tempting.
Well, do you have any thoughts as to how the inflow of drugs from South America might be controlled or
Well,
modified?
this book, Narcotic Drug Addiction Problems, takes an international look at the and a historical look at the perspectives of drug addiction, and I think it makes much more sense than the present legislative and judicial practices in this country.
Mm-hmm. Well, now you have some chapters here in some of these other books, it's Frontiers of Science.
Well, this Frontiers of Science I didn't have anything to do with directly, but this shows an image taken from our reconstruction from brain slicing of a whole human brain with colors added to color cortex and basal ganglia and thalamus and brainstem and so forth. And this was attractive to the National Geographic, and they published this book, and it shows, it's called Wonders of the Brain. That's pretty spectacular. And then it shows a couple of us digitizing a brain mm-hmm. using a computer mouse to define boundaries of structures. It's this way that we built the film, and the film produced in 1976 was introduced as its premiere at the American Neurological Association meeting in San Francisco in June of 1976. And I stood at the door exit when people were coming out, and one of the remarks that I cherish is a wife of one of the neurologists, and as she came out, she said, "After seeing that film, I'm going to take much better care of my brain." At any rate, that film won all national and international awards, and the State Department wrote us a commendatory letter based on the international promise of that documentary film. One of the things that you and I did was to make a film for CBS called Conquest. And that was a great pleasure, Earl, to work with you then. That was in 1957, mm-hmm. and Eric Severide was the moderator.
Yeah.
And we had an operating room scene where you were operating on a patient under local anesthesia, and you could ask him to make some movements, and then you could generate some movements mm-hmm. by stimulating cortex and so on. A very illuminative exposure of neurosurgical techniques and promise, and it was concerned with reticular activating system and with other problems that you and I are devoted to. And that again won the Thomas Alva Edison Award for the best documentary in science mm-hmm. for 1957. And it's still being shown. It included work
kind of out of date now, though.
It included work by Neil Miller and Jim Olds and other people, and it's still pleasant to look at. And nothing's wrong with it. It just should be updated
Sure.
to add new information. This is a little book called Sensory Processing, Perception, and Behavior. This is based on several chapters I wrote for a handbook of psychology for psychologists, and then the chapters that I wrote were put together in this handbook. One of the things that is celebrated in here is the fact that the brain has an effect on its own input. It can control by centrifugal fibers going out to sense organs, the retina, the cochlea, and so on. And sense organs like the muscle spindle, it can control afferent input, and can control that afferent input not only at the origin but at each successive relay going back toward the higher centers, so that we don't live in a world where our sense organs contact the world without bias, but our past experience, expectations, and purposes all modify what comes into our brain, and as well as what we remember. So that's, to me, that's kind of exciting and enlarging for the public knowledge as well as professional knowledge of how the brain works.
Well, now, you've been telling us some of the very interesting aspects of your scientific work. For this, you've received a number of honors. Would you tell us about those?
Well, they're not very honorable or very spectacular. I was the Sachs lecturer at Dartmouth College. I was given the Matrix Midlands Award for Excellence in Science in 1980-81, the top award of that year. I was asked by AAAS and Sigma Psi to give lectures to all the science students, honor science students of high schools in Florida and in Oregon and some other states. And that was quite a lot of fun.
Yeah, did you have to go around to these various states and
no,
give lectures?
They got all the students from Florida to come to one location and
see.
Stay in a big hotel and have access to a big auditorium so that I could talk to them all at once and show slides and have some interaction, questions and answers and so forth. But it was very exciting to contact young people who already had demonstrated an interest and excellence in science studies and be what they called a holiday lecture series. This was because these occurred during the Christmas break. And I must say the students were marvelous in Florida, Oregon, and Missouri, and some other states. And then we made another tour for Sigma Psi to lecture in a whole bunch of cities up and down the East Coast, again about neurosciences. Also, I must say, it was a great honor and privilege to work with Frank Schmidt, who was university professor at MIT. And Frank Schmidt organized a neurosciences research program. In fact, the name was invented using neuroscience as a composite of disciplines. And he had 34 scientists of international reputation gather together 3 times a year in Brookline, Massachusetts for dialogue. And it was cross-disciplinary so that people were talking about anatomy and physiology and clinical and molecular biology and genetics and everything else, and it was wonderful. And there were shelves of books that have been published, edited by Ted Melnichuk, very exemplary contributions. That organization is still alive, and it's headed now by Jerry Edelman. He's building an institute in La Jolla for continuation of the neurosciences research program. I think that that's one of the hopeful and exciting prospects, is to have institutional, organizational competence at a very high level be supported and continued. Also, neurosciences as a society was started about 1962 or 3, and that is the fastest growing professional organization in the world, I think.
Mm-hmm.
And it has succeeded in having a number of publications and annual meetings and so on. The present president is a member of our community, a man named Larry Squires.
Oh,
And
yes.
very happy to acknowledge that Larry's a leader in neurosciences. He's been interested in mechanisms of memory.
Right.
Well, I see nothing but a great future for America, and particularly for the world as a whole, if we can achieve global cooperation. I talked about that before, but I think the neurosciences is an access to people's imagination and understanding to show that human nature is plastic, is affected by culture, and we aren't rooted genetically in wars. The genetics that we have not much changed by selection in the last 30,000 or so years, covering all of civilization, we are not bound, in other words, to the kind of massive destruction that we're cultivating at the present time. Our technology has just run out of good sense. I was talking about this with you in respect to McNamara and Elliot Richardson and Cy Vance and Harlan Cleveland and others. And what we intend to do is to have a worldwide symposium by electronic means so that people can be deciding what are the priorities, what are the significant principles, and who are the principal actors, and what are the financial penalties and so on, to both avert catastrophes and to rectify neglected opportunities. I'll give you an example. I spent about 7 years worrying about nutrition affecting human brain development, and using the best nutrition surveys, the 10-state nutrition survey and the preschool nutrition survey done between 1968 and 70. Using those data, we determined that with very strict criteria, that not less than 2.4 million children under 4 years of age in the United States were suffering from serious brain jeopardy. And this jeopardy amounted to roughly 10% of the loss of volume of their brain. You take 10% away from a computer and you've done it grave damage. And since this affects the child for the rest of his life and reduces his strategies and perceptions and judgments and behaviors, it's a very severe penalty. And it doesn't cost very much to ensure that everybody gets fed adequately in pre-pregnancy, throughout pregnancy, period of lactation, and at least to the 4th birthday, and hopefully through the mid-adolescence. If children receive adequate nutrition in that period, then they can live up to their genetic potential. But it's true that many of them cannot now. And we believe that judging by the number of children in poverty now, that number has doubled since 1970, so that there's in the neighborhood of 5 million kids in the United States who should have been well fed and who weren't. And this is an unconscionable experience. We are penalizing the families and the children. Now, our data were taken in 1975 to a number of economists, and economists were asked, what does it cost to feed the kids, and that's cheap. What does it cost to not feed the kids, and that's expensive. And they said for every dollar that is presumably saved by neglecting to feed women, infants, and children in the period of rapid brain growth, for every dollar saved, you were spending $50 to $70 for job education, for education in schooling, for return on income tax and so forth, quite apart from the human side of reduction of creativity and life performance. So a crusade that I would like to see everybody in the American Association of Neurological Surgeons join is a crusade to have adequate nutrition for pre-pregnant, pregnant, lactating women, infants, and children. So we have established a program in Tibet in honor of His Holiness the Dalai Lama. Nancy Harris, a graduate of Stanford Medical School, is running this program, and she has full information on what kinds of foods are available in Tibet, what their nutritional values are, what is needed by way of supplementation, and she will provide supplementation. And there's an educational program for women and infants, and not infants, but women and adolescents and teachers and nurses and physicians and so forth in Tibet. And she's done this so skillfully that the Chinese have not objected. In fact, they're so excited about it themselves in Tibet that they would like to see the World Bank support a program for all of China that would ensure this. I think the United States should be at the lead of this kind of activity. So the Dalai Lama is very happy about that. I've told him that he can be as concerned as he might wish about the preservation of the traditions and the language and the literature and the customs, music and so forth for Tibetans. But if the children aren't adequately nourished, then they have suffered a terrible penalty for the subsequent generations. And I think that in the developing world that there's no investment that could be made that would be comparable in return as compared to feeding kids adequately during the period of rapid brain growth.
Yes, you were speaking of this country alone, but if you look at other countries in the world...
Oh, they're much worse off.
Oh, yes.
Many of them are. Some are better off, the Scandinavian countries in general, but most of the world, in fact, there are almost 2 billion people who are suffering extraordinary poverty and hopelessness. And many of those people are without adequate resources for nutrition. It's a terrible shame, and one that is kind of counterbalance. War is the chief stupidity of man, but neglect of children's brain development is another signal, cardinal stupidity. We ought to get rid of war, and we ought to enable children to live a full life.
Well, this has been very interesting indeed. Let me ask you another question, a little bit aside from what we've been talking about. You've discussed the developments in the computer science and what may be done. Is there any reason to continue having big meetings such as we're having here now? Cannot all of this information be disseminated through computers in your own home or in your own laboratory or office?
Well, Earl, I think, number one, that there are big advances, some of which I've touched upon, that will enable us to have quick communication by satellite and by the new highway of information. And it will be possible to have stored information in accessible things, library resources and so forth, through electronic access. And it will be possible to have stored information in your home in compact discs and other kinds of accessible material. But there's nothing to compare with face-to-face contact, with the eye-to-eye contact between teacher and student, between colleagues. And I think that we should preserve meetings for the social contact, for the contact of somebody talking about his new research and clinical findings and so forth, so that people can celebrate it together. We're social animals, and if we become too obsessed looking at the screen, we're not only subjecting ourselves to micro-radiation that may not be very wholesome, but we are also denying ourselves the interactive pleasures and actually the memorable pleasures, the kinds of pleasures that anchor themselves indefinitely in one's mind and imagination. For example, our interaction to make a film in 1957 is one of the highlights of my life, and our interaction now is a great honor and pleasure.
It's really been my pleasure. You have a number of photographs here. Are there some points there that you'd like to bring out?
Oh, here's a picture of my wife at the helm of our boat sailing. We were going from, it wasn't our boat, as a matter of fact, it was a borrowed boat, but we were going from the Virgin Islands to Bermuda at this time, kind of a quiet day. I'm fixing a lure for catching some fish, and she's looking out through her reflective glasses. This is me climbing Mount Hood one time in summer, spring climbing. This is me this is our boat this time. This is the Estrella, which was the Alden 44-foot yawl, which we enjoyed so much. This is a picture when I was graduated from university. Let's see. Here's a picture that came from the program that you and I were involved in. This is Eric Severide and me looking at a cat that Ed Everts had implanted some electrodes, and he was causing the cat to wake up by stimulating his reticular activating system. Let's see. Here's my beautiful wife. Here's a picture of my wife and 3 daughters. Here's a picture when I was at Yale with a mangabey monkey. Here's a picture of, let's see, here's a picture when I was in elementary school. Oh, here's a picture I like very much. This is a picture of my brother and me. My brother, 4 years older, Kenneth, a neurosurgeon who practiced went to Harvard and practiced in Boston and at the Leahy Clinic and in Portland and in Toronto, and worked for several years in Iran to help create a medical school in Pahlavi University. And myself, as little kids, we had a great time. This is a picture of my mother.
Very beautiful.
Lived to be 94. I showed you my wife in the boat. Here she is in the studio. Oh, here's a picture when I was at Oxford working with Paul Glees. It's a small sort of passport picture. And this is a picture that this is a series of 3 pictures that I enjoy very much. This is taken by Adam Engel while we were having one of our dialogues. This one was in 1987 in Dharamsala, in His Holiness's chambers, in his government in exile. And I was explaining here the 3 layers of the embryonic nervous system.
Oh, yes.
And I got him to present his hand so that I could make a sandwich like this to make the 3 layers, and then identified the 3 layers and showed how development occurred. And then we went on to discuss other things, and we had capital time laughing together. And he's a very humble and good-humored, enjoyable person. I just wish that this country would pay more attention to human rights as they are being exploited unmercifully by the Chinese in Tibet at the present time. And between 1949-50, when they invaded Tibet, and the present time, more than 1 million million Tibetans have been killed by the Chinese, and they're still molesting and beating them up. And they also are disgracefully spoiling the habitat. They have removed, by their own account, $58 billion worth of timber from Tibet, and that's changed the dry adiabatic column of air rising from Tibet, which has changed the climate and the air content of moisture clear across the Pacific and affecting both coasts of the United States. It's an unconscionable kind of thing. And they also have put radioactive waste from Lop Nor in Tibet without fences, without warning, so that nomads and others in even remote areas will be exposed to unconscionable. This is a picture of me when I retired in 1987. That's a long time ago already.
Yes.
I guess that's all. Oh, here's a picture of me as an intern
Oh, yeah.
at Stanford University Hospital. That was a great experience with
Well, are there
good company.
any last words that you'd like to say before we close this interview?
Well, I think one of the most sacred professions in the world is neurosurgery. I think that contributing to insight and to curing people of pain and discomfort and disability, epilepsy and so on, by neurosurgeons is one of the most elegant and uplifting enterprises of human endeavor. It's a highlight for me, for the world. I'd like to see us concentrating on enabling that kind of activity to be at the forefront of our attention, and that we could realize how much better the world could be if we could invest in these kinds of things rather than in nuclear stuff. For example, during each of the 4 years of the Bush administration, the cost just for nuclear control of weapons, for manufacture and design and so on, was greater than the total domestic funds of the United States budget every year. And we're continuing that now in the Clinton administration, and it should be stopped. We should not be spending money on something that's so counterproductive to human equanimity and human progress. I think that if we paid attention to human suffering, human need, human options, human opportunities, if we committed ourselves to educating people thoroughly about themselves, about nature, about their interdependence with other people and with nature itself, that we would have all the resources necessary to make the world much more habitable, much more fair, with much greater justice than it is now. So that would be my proposal, that we concentrate on those things. And I think neurosurgeons ought to be not necessarily on a soapbox, but they should be telling their patients and their students and their colleagues and the world at large that it's very important to consider the kind of world we would like to have and work for that, work toward that, commit ourselves to doing it.
Well, do you not think that the medical profession is becoming much more aware of the necessity of the social interplay that is necessary?
I do, Earl. I think that the medical profession is not only the next oldest profession in the world, but it's probably the most honorific. For instance, in antiquity, the contract between a patient and a physician, which is assumed the minute the patient presents himself to a physician and the physician says, "I will agree to care for you," that contract is a contract called philia. That means friendship. That means that the doctor will do everything for the patient that he would do for a friend. He will do nothing to the patient that he would not do to a friend. This is one of the noblest contracts in the world. It should be celebrated, and doctors should know about it if they don't already, that we are working for friendship, with friendship, on friendship grounds, and our responsibilities are not only to the immediate patient, but to all of the potential contributions to that patient from the environment, from the war propensities that present-day nations have so callously exercised. No, I think that there's great hope, and there's a great responsibility that lies with physicians, and I would say with neurosurgeons in special degree.
One other question. I understand that you were associated with the space program of NASA.
Yes.
Could you tell us something about that?
Yes, Earl. When NASA was first created in 1958, it had been the aeronautical NACA. Anyway, they converted it to NASA, the National Aeronautic and Space Administration, and they appointed a Life Sciences Committee to help fulfill John F. Kennedy's idea of going to the moon. In October of 1958, then, there was assembled a small committee under the chairmanship of Randy Lovelace. And this committee was to decide on what were the safety requirements, what were the communication requirements, what were the emergency bailout requirements and rescue requirements and so forth, what were the nutritional requirements, and what were the potential damaging effects of space life. And then we had the opportunity to select the first astronauts and to work with them in training. I worked very closely with Vern Grissom, who was one of the first astronaut team, and he unfortunately burned up in an accident fire in one of the ground tests. But I knew all the first astronauts and was very excited about that program.
Did you have an opportunity to examine these people after they came back from?
Yes.
There?
Yes.
And did there seem to be any change at all that might be detected?
Well, there was some loss of calcium, and there was some loss of some of the reflexes relating to balance and coordination.
Were these permanent, or were these
No, these were relatively,
lasted for how long?
relatively modest. Well, you may remember that Gagarin, who was the first man to orbit the Earth and was up in space for quite a while, he staggered when he got off and was doing his politicking afterwards. By having some exercise regimes in orbit, it compensated for much of that disability, and having a social interaction was also helpful, and having adequate communications. So I think the program has been progressively improved for the safety, security, and well-being of the astronauts.
So there's no evidence of permanent impairment of their vestibular system or any other part of the nervous system?
I know of none, but I'm not staying abreast of these things.
Mm-hmm.
Now, there's one other thing that was possible to participate in when I was in Washington. I was invited to be an adjunct professor in the school for the State Department, which is called the Mid-Career Development Program. The State Department has a numbering system where they go from higher numbers to lower numbers as they progress. It's the reverse in most of the rest of government. And when people are going from 6 to 5 or some such level, then they are allowed to have a year for study in this mid-career development program. And I taught them neurophysiological and neurosciences kinds of things, particularly perception, judgment, and behavior, which I think are very germane to the State Department.
Mm-hmm.
I taught that for 11 years and enjoyed it very much. I don't know whether it had an effect on the State Department, but I made a good effort, and the State Department was very cordial.
Well, you met some very interesting people during that time.
I certainly did, yeah.
Yes, it must have been an exciting program.
One of the things about it was that they let other people, some of the military branches and the CIA and FBI and so on, come into that program, and I hope that the kind of contribution I could make has been useful.
We want to thank you for this fascinating interview and appreciate very much your concerns and the suggestions that you have made. Thank you very much indeed.
Earl, it's a great pleasure and honor both to be associated with the American Association of Neurological Surgeons and to greet you and be interviewed by you.
Well, thank you
Earl.